Hello everyone, good afternoon. I'm Namrata, PhD student at IIT ISM Dhanbad. So, this is problem solving session week 7 for the course Differential Equation for Engineering, in which we will discuss problems related to your lectures. So, okay, just wait. Okay, these are the question we will discuss today's lectures. So, in your lecture series, you have learned about Sturm Liouville problems and their eigenvalues, their eigenfunctions. So, basically, this doubt solving session related to this topic, Sturm Liouville problems and their eigenvalues, eigenfunctions, all these things. So, okay, the problem number 1 is find the eigenvalues and eigenfunctions of the Sturm Liouville system y double dash plus lambda y is equals to 0, where boundary conditions are given y0 and y dash 1 is equals to 0. Please try to solve question number 1 and give me the answer. You have to find eigenvalues and eigenfunctions. Question is clear? Are you trying?
Yes, ma'am.
Okay. Can anyone tell me how to proceed this type of problem?
So by using the we have to consider three cases. Lambda
Yes.
is equal, lambda is positive to 0 and lambda is negative.
Yes. And apply boundary conditions and
Yes,
find
and
out
apply that.
the arbitrary constant so that we can find the eigenvalues and eigenfunctions. So let's take, we have to calculate eigenvalue, eigenfunction. So if lambda is equals to 0, the first case when lambda is equals to 0, then what will be the solution? If this is equation 1, put lambda is equals to 0 in equation number 1, then y double dash is equals to 0. So the solution will be now you have to apply the boundary condition. Put y0 and 0, that means x0 and y of x0. So from here c2 will be 0 and y dash is equals to 0. That means derivative of y, which is c1, and y dash 0 is equals to 0. So c1 will also 0. When you put c1 c2 in this equation, then you will get yx 0 for lambda is equals to 0. So lambda is equals to 0 cannot be the eigenvalues. Is it fine?
Yes, ma'am.
Okay. All of you? Krishna Swami? Are you getting?
Yes, madam.
Okay. Now case 2. If lambda is negative number, uh, if lambda is negative, let's say minus mu square, then you have to substitute lambda here in equation 1. Then what will be the value? What will be the solution? Okay, let's see. Tell me the solution. What is the solution in this case? Okay, auxiliary equation. Roots are plus minus mu. That means y of x c1 e की power mu of x plus c2 e की power minus mu of x. So this is the solution. Now again while applying the boundary condition, equation 1, after applying the second boundary condition, y dash x in this case mu c1 e की power mu of x minus, I am taking mu outside, So apply boundary condition. So you have to solve equation 1 and 2 and find the value of C1 and C2. Tell me the value of C1 and C2. Equation, this is equation 3 and 4 because we have already taken equation 1 and 2. This is also constant. E की power mu, e की power minus mu is also constant, or we can write e की power, if we take e की power minus mu common, then we can write, and since mu is not equals to 0, so this will 0. Now C1 is equals to minus C2 and is equals to 0, and from here if we put C1 is equals to minus C2 or C2 is equals to C minus C1, we can put both, any one of them. Then from here C2 will 0. Also C1 will also 0 because C1 is equals to minus C2. Is it okay? You have to check C1 and C2 both are 0 in this case also. Two equation, two unknown, you have to solve. Take C2 outside, the remaining term cannot be 0, so C2 will 0, that implies C1 will 0. Is it okay? Okay. From here, what we can say? Y of x 0. That means lambda minus mu square cannot be the eigenvalue. Now case third. If lambda is equals to mu square means positive, then in this case auxiliary equation, the roots are Is it okay? These are the roots. So what will be the solution? C1 cos mu x plus C2 sin mu x. Now again the conditions, boundary conditions are y0 is equals to 0. Put x is equals to 0, then this will become 0 and C1 cos 0 is 1. So C1 is equals to 0. Now y dash x multiply y dash 1 is equals to 0. So this will become 0, and second term c2 mu cos mu of 1 means cos mu. So if we take from here c2 is since mu is not 0, okay, and if we take c2 0, then again we will get y of x 0. That means we cannot find any eigenvalue if we consider in this case also c2 is 0. So if c2 non-zero, then cos mu will be 0. Is it okay? For non-zero solution, in this case, we have to consider c2 non-zero, so that cos of mu is equals to 0, and from here what will be the value of mu? Where n is 1, 2 and so on. For non-trivial solution, because if we consider c2 0, then again we'll get trivial solution, but we have to find the non-trivial solution. Is it fine?
Yes, ma'am.
Okay, so the value of mu is 2n minus 1 pi. Now substitute this value in this equation number 5. Okay, c1 is already 0, so this will vanish, and if you take c2, because c2 is arbitrary constant, you can take c2 1 also, or you can take anything. So after putting, you will get sine 2n minus 1 pi by 2 x, where n is 1, 2, 3. So therefore these are the eigenfunctions corresponding to the eigenvalue. What are the eigenvalue? Lambda is equals to mu square. Lambda is eigenvalue. So lambda is equals to mu square, and mu is 2n minus 1 pi by 2. So here corresponding to the eigenvalue 2n minus 1 square pi square by 4, where n varying from 1 to and so on. So this is the eigenvalue, and sine 2n minus 1 pi by 2 x, where n is 1, 2 and so on. This is the eigenfunction which we have to calculate, and we have already. Okay, tell me if there is any doubt in this question.
Ma'am, is it not required to write C2 term in the eigenfunction?
Eigenfunction, you can take c2 also, because c2 is arbitrary constant, so you can take c2 1 also, or anything, some constant, because it is arbitrary constant. You can take c2 also here. This will also correct, and you can remove c2 and put the value c2 is 1. It will also correct. Both are correct answer.
Okay.
Please see the solution. If there is any doubt, then tell me. I'm trying to go little slow because maybe yes, Sukhendu.
Hello, ma'am.
Yes,
Now, why we check only for real values of lambda?
because lambda is a real constant. So we have to consider three cases which will cover all the real numbers. In case 1, we'll consider 0, and in case 2, we'll consider negative, and case 3, positive case.
Means here lambda is real, okay?
Yes, yes, lambda is real. So we have to take three cases so that we can cover all the cases for real numbers. Lambda
Okay.
is real number. You can write. Okay, move to the next question. Question number 2. The question is, find the eigenfunction and eigenvalues and eigenfunction for Sturm Liouville problems or system problem. Now you have to solve this problem because this is the exactly same to the question number 1. In the domain this is width take three cases and solve the problem. And give me the answer.
No solution for case 1 lambda is equal to 0.
Yes, correct answer. So the question is, Find the eigenvalues, eigenfunction for the Sturm-Liouville problem y double dash plus lambda y is equals to 0 in the domain 0 to pi with boundary condition y0 y pi is equals to 0. Again we have to consider for lambda there are three cases: 0, positive and negative. Okay, consider case 1, lambda is equals to 0. Then I am going to write the solution. Is it okay? This will be the solution. In previous manner, in question number 1, the system, in both the question the system are same. The difference in the boundary condition only. So this is the solution. Now you have to apply the boundary condition. From 1 you will get C2 0, and from 2 you will get C1 0. That means you will get yx 0. So lambda 0 cannot okay. Now case 2. Again, what will be the solution? We have already solved this in question number 1 also. Krishna Swami, can you please tell me the solution in this case?
Just a minute, ma'am. But in this case also C1, C2 is 0.
Okay, C1, C2 is 0. But I am asking what is the solution for this differential equation. Tell me first of all the solution for this differential equation.
Y of x equal to 0.
After applying boundary condition, you will get y of x is equals to 0. But before that, what will be the solution for this equation? Without boundary condition, what will be the solution?
Plus or minus mu will be the roots.
Yes.
Okay,
So,
that one. C1 e raised to mu.
plus C2 e raised to the power minus mu of x.
Yes.
Is it okay?
Yes, madam.
Now you have to apply boundary condition. Okay, you can mute yourself. Thank you. Okay, after applying, you will get C1 plus C2 is equals to 0 from first one, and from second one you will get from these equation you will get C1, C2 both will 0. So y of x will 0. So minus mu square cannot be the eigenvalue. Consider case 3.
Ma'am, can you please show me once again the solution? C2.
Is there any doubt?
Ma'am, for example, so if I substitute the second boundary condition,
Yes. Okay, here pi. This is pi.
yeah.
Yes, this is pi. 2 mu pi. If we take outside e की power mu pi, then from here we left with 1, and from here e की power 2 mu pi, and take outside, put the value of c1 is equals to minus c2 in this equation, and take outside. The rest of the thing cannot be 0, so c1 will 0, and from there c2 will also 0. Is it fine?
Ma'am, for example,
Yes.
C1 e to the power of pi mu plus C2 e raised to minus mu pi is equal to 0 will be the second solution.
Yes.
If we substitute C2 is equal to minus C1,
Yes.
then it will become, can we write multiply and dividing 2C1 into sine hyperbolic pi mu.
Again, the term you will write sine hyperbolic, then the sine hyperbolic cannot be equal to 0. So, what is the value of sine hyperbolic?
No, here again it will be depends on mu only.
Yes.
Mu is not equal to 0.
Yes. So, mu is not 0, so the term cannot be 0. So, the coefficient C1
will become
will
0.
be the 0. Yes.
Oh.
Now consider case 3rd. Okay, in case 3rd, we have already written the solution in question 1. So I am going to write the solution. Now you have to apply the boundary condition. While applying this boundary condition, you will get C1 0. While applying this boundary condition, C2 sine mu pi. For trivial solution, for non-trivial solution, for non-trivial solution, if C2 not 0, that means sine of mu pi will 0. From here, what will be the value of mu pi? Sin n pi. Mu is equals to n. Is it fine? So put the value in this equation. C1 is 0 and C2, we have considered C2 non-zero, so C2 is arbitrary constant. We can take 1 also, or we can left with C2, and after putting mu is n, then what will be the value of eigenfunction? Put mu is equals to n in equation star. What will be the eigenfunction? Since C1 is 0, so this
Sin
term,
n pi.
yes, not pi, only mu is n, so sin nx is the eigenfunction. The set here, you have to put mu is equals to n simply, and C1 is 0, so the first term will vanish. The set is eigenfunction. Is it fine? And what will be the corresponding eigenvalue? Lambda. Since lambda is mu square, so mu is n, then what will be the lambda? N square. Are you getting my point?
Yes, ma'am.
Okay. So eigenfunction corresponding to the eigenvalues, n square, where n is 1, 2 and so on. Fine. Is there any doubt in question number 2? You can ask me. Otherwise, we can move on to question number 3.
Few seconds previous page.
Yes, sorry.
Few seconds. I want to see previous page.
I'm not getting your query. Can you please repeat?
Okay, madam. Correct. Just wait, madam. I will cut.
Okay. I will provide the link for this lecture PDF, so you no need to worry about the notes.
Okay, madam. Okay.
Okay. Let's move to the next question, question number 3. Again, eigenvalue and eigenfunction. The problem is x, y dash, all dash plus lambda upon x, y is equals to 0, and the boundary condition of y1 0 and y of e 0. Please try to solve this question. Okay, please try to rewrite the equation and okay, can we write this term as xy double dash plus y double dash? Can we write first term as the differentiation of product of two terms, because here x y dash ka whole dash, that means the differentiation of x y dash. So the first term can be written as x y double dash plus y dash, and rest of the thing, or if we take x, then here is it fine? Lambda by x here, so take x LCM, then you will get x square y double dash plus x y dash plus lambda y is equals to 0. Now by the change of variable, we have already done this in lecture 5 or 6. By change the variable z is equals to log of x, the differential equation become, can anyone tell me, after change of variable?
Cauchy's equation.
Yes, you can solve with Cauchy's equation, but we have to convert this equation by change of variable so that this problem can be reduced in Sturm-Liouville problem. This is also a Sturm-Liouville problem, but if we have to convert in this form, standard form, like this, or in question number 1, so what you have to do, just transform this equation, by substituting z is equals to log of x. Yes, it is Cauchy's problem. So what will become differential equation? Can you tell me the differential equation? Here the
d of d minus 1 of y plus dy plus lambda y is equal to 0.
okay. So you are telling the after transformation you are telling the auxiliary equation. Am I right?
Hmm.
But no need to write the auxiliary equation. First of all, we have to convert the because we are applying the change of variable. So at the place of x means this is here the x is dependent variable, but we are going to change the variable. We are going to reduce the equation 1 into the dependent variable z. So what will be the equation?
d2y dz2 plus lambda y equals 0.
Yes, correct answer. So Let me explain little more. What will the value of dy by dz? We have already used the chain rule in previous lecture. What is the dx upon dz from here? What is dx upon dz? Dx upon dz is, differentiate this equation with respect to z, you will get e ki power z, and this is dy by dx. So dy by dz is e ki power z dy by dx. Okay, so again d2y by dz square, what will be the value of d2y by dz square? Can we write it as, and from previous, although dy by dz is e ki power z into dy by dx, so can we write e ki power z dy by dx from above? Is it fine? Now product of differentiation of two functions. Sorry, this is z. Now what is dy by dz? Again we can substitute from above e ki power z dy by dx. E ki power 2 of z d2y by dx square plus e ki power z dy by dx. So y double dash e ki power 2z plus e ki power z y dash x. Is it okay? Now from previous equation, substitute x is equals to e ki power z, x is equals to e ki power z, and we are converting x into z. So this term will become y double dash z from here. Can you see it? Differential equation become y double dash z plus lambda y of z is equals to 0. Is it fine? Is it fine?
Can you once again tell me how?
Okay, we are converting this equation 1 in which x is dependent variable, y is independent variable. Now we are converting the change of variable, that means we are converting the dependent variable x into z. So we are applying z is equals to log of x. From here x will become e ki power z. So what will be the value of dy by dz? Applying chain rule, dx dx. Okay, then from here dx upon dz is e ki power z dy by dx. Now we have to calculate second derivative also, d2y by dz square. So using first derivative dy by dz, put the value of dy by dz, because we have to change the dependent variable x into dependent variable z.
Yes, ma'am.
Substitute this value and apply differentiation of product of two function. Leave the first one, differentiating second. I am exchange dx and dz here, and leave e ki power differentiation of e ki power z with respect to z is remaining e ki power z. Again put the value of dy by dz, you will get this. Take outside e ki power 2z, because here the outside d upon d of x is written, so you can take e ki power z outside, so you will get this equation. Is there any doubt till now?
No, ma'am.
Okay, so what will become? Y double dash z is e ki power 2 of z, y double dash of x, e ki power z, y dash of x. So after substituting at the place of x e ki power 2 of z, here the term become e ki power 2 of z, and y double dash of x plus e ki power z y double dash of x will become from here you can write y double dash z. Is it fine?
Yes, ma'am.
Okay, so now the system become similar to the system we have already done in question number 1, question number 2. Also, what will be the boundary condition? Because z is log of x, and boundary condition is y1 is 0, y e is equals to 0. When x is 1, then z become 0. Fine. From here, when x is e, you will get z is equals to 1. Log of 1 is 0. No, sorry, log of e, and base is e, so log of e is 1. What will the boundary condition? Boundary condition will become y0 is 0, y of 1 is 0. Is it fine?
Yes, ma'am.
Okay. Now the system become y double dash of z plus lambda y of z is equals to 0 with boundary condition y0. Now you have to solve this problem. You can easily solve in previous manner. In problem 2 we have also done these things, so no need to solve in this question again. So I am going to write the eigenvalues and eigenfunction. In problem number 2, the eigenfunction we have already get sin nx is the eigenfunction. So at the place of x, here the system is nz. So sin of n at the place of z, it is log of x. Is it fine? Because we have already solved this question in problem in question number 2 also, in which we have already obtained the eigenfunction sin n of x. Because here z is independent variable, so at the place of x we will write z, and z is log of x. So the eigenfunction is sine n log of x. You can write this system is similar to, okay, I'm going to write in a nice way. Okay, let me show you the problem 2. So this was problem 2. Just because boundary condition are different, so in the last we have obtained the eigenvalue sine nx. At the place of x will get in this case we'll get sine n pi. After applying at the place of 1 you will pi, you have to apply the boundary condition, this y of 1 is 0. Original system. N pi square. I am skipping the calculation just because we have already done this in question number 1, question number 2 also. In question number 2 and question number this problem, the only difference is boundary condition. When you apply this boundary condition, you will get the eigenvalues n pi whole square, and the corresponding eigenfunction you will get sine n pi. At the place of z you have to substitute log of x. Is it fine?
Ma'am, is it pi square or
Sorry?
Eigenvalue is
Yes.
it n pi whole square or only n square?
No. In after applying boundary condition, in this case boundary condition is y10, and in previous question the boundary condition was y of pi is equals to 0. So when you substitute in last case sine n x is equals to 0, then you will get sine n pi is equals to 0. So you will get mu is equals to n pi, not just n. Okay. In previous question you will get mu is equals to n, and in this case after applying the boundary condition you will get mu is equals to n pi. You can check because this is similar to question number 2. Is there any doubt? Anyone else? You can ask. Shall we move to the next question?
Yes, ma'am.
Okay. Now the question number 4 is, the system is e की power 2 of x y dash whole dash e की power 2 of x lambda plus 1 is equals to 0, where the boundary condition are. Now again you have to rewrite the differential equation. and find the general solution one by one, considering the case of lambda. Try to solve. Okay. Write the differential equation equivalently as e to the power 2 of x y double dash plus 2 e to the power 2 of x y dash of x e to the power. I'm just differentiating these terms e to the power 2 of x y dash of x, because the outside again there is a dash, means differentiation of e to the power 2 of x into y dash. So now you can take e to the power x common, and since e to the power 2x cannot be 0, so the equation become this is double derivative. Is it fine? Okay. So now consider if lambda is equals to 0, case 1, then you will the roots will from here minus 1 are the roots, so the solution will get c1 e to the power of x minus f x plus c2 x into e to the power minus repeated roots. You will get minus 1, the roots of auxiliary equation, and the solution you can write as y of x c1 e to the power minus x plus c2 x into e to the power minus x. Now you have to apply the boundary condition. Y pi of 0, both from 1 you will get c1 0, and from 2 again you will get c2 into pi into e to the power minus pi. That means c2 is 0. Is it fine? Because c1 0, so here
Yes, ma'am.
c1 is 0. Okay, so because c1 c2 both are 0, so this solution will become yx is 0, yx identically 0. That means lambda is 0, so lambda 0 cannot be the eigenvalue. Now consider case 2. If lambda is minus mu square, you can write mu not 0. So what will be the equation become? The differential equation will become can you solve and tell me the roots of auxiliary equation for this differential equation?
So roots are -1 minus mu minus 1 plus mu.
Yes. So you can calculate the roots. I'm not going to calculate. This is the auxiliary equation and simply you have to calculate the roots. From here you can find the roots. The roots are e की power -1 plus mu and another roots are -1 minus mu. You can calculate from here. I am not going to calculate the roots. So the condition, the boundary condition, after applying boundary condition, by the first boundary condition c1 plus c2 0, and from the second boundary condition c1 e की power mu of pi plus c2 e की power minus mu of pi. So can you solve these two equations and tell me the value of c1 and c2? Equation 3. Put the value of c1, c2 in this equation. Again, take c1 outside. E की power mu pi minus e की power minus mu pi.
Not trivial solution.
Yes, c1, c2 both will become 0 in this case. So y of x identically 0. That means lambda minus mu square cannot be the eigenvalue. Now if lambda is mu square where mu not 0, then the differential equation become now again you have to calculate the roots from the auxiliary equation. You can check. I am going to write the roots of this equation. So you will get the imaginary roots -1 plus minus iota mu in this case. You can check. So the solution This will be the solution. Now, is it fine? Can you check the roots? And for the given roots, can we write the solution as? Are you getting these steps? This is quadratic. You can calculate the roots. The roots you will get -1 plus minus iota mu. So the solution will become this. Okay. Now you have to apply the boundary condition. After applying this, you will get cos 0. Cos 0 is 1, so C1 into 1, and these things become 0. So from here C1 is 0. Now applying the second boundary condition. What is the second boundary condition? C pi is equals to 0. So e to the power minus pi. Although C1 is 0, so I am not going to write this term, first term, and the second term is C2 into sine mu of pi. So again, for non-trivial solution, let C2 is not 0 and e to the power minus pi cannot be 0, so sine mu pi will be 0. And from here not x, where n is. So the mu is n. Fine?
Yes, ma'am.
Okay. If there is any confusion, you can ask me till now. Now this is the eigen value. This is not the eigenvalue. Lambda is equals to mu square. So the eigenvalue will n square. Isn't it? The eigenvalue will be n square, and after putting mu is equals to n in this equation, let's say this is equation numbering. Okay, you can correct the numbering. I am going to write it. This equation is 4. From equation 4, the eigenfunction is the set sign. At the place of mu you have to write n, so the eigenfunction are sin nx, and e to the power minus x is also in the product form. Corresponding eigenvalue fine? Is it fine? If there is any confusion, any doubt, you can ask me. Because I am going very slow, so you can ask me. Okay, I think there is no doubt. Okay, move to the next question. Question number 5. The question says expand the function f of x is equals to e की power x in terms of the eigenfunction of the problem third. You have to expand the function e की power x in the term of eigenfunction. We have solved the eigen problem 3 and we have already get the eigenfunction. So in problem third, okay, what was the problem third? So sine n pi log x is the eigenfunction, isn't it? In this problem number third. So problem fifth says expand the function f of x is equals to e की power x in terms of the eigenfunction of the problem third. So you have to expand the e की power x in terms of sine n pi log of x. Question is clear? You have to expand the function e की power x in terms of the eigenfunction for this problem. The eigenfunction is sine of n pi log of x. So you have to expand the function e की power x in terms of sine n pi log of x. Is it fine? Hello.
Yes, ma'am.
Okay. Question is clear. So you have to expand e की power x in terms of eigenfunction sine n pi log of x. So I'm going to write the problem because we have to calculate Cn. Okay. The problem was xy dash lambda by xy is equals to 0. Okay, just wait. So comparing with have you learned about this equation in your lecture series?
Yes.
Okay, now you have to compare this equation with this, then you will get the value of p of x, q of x, w of x. What will be the w of x? P of x is x, Q of x is 0 and W of x is 1 by x. Is it okay? Comparing with equation 1. Okay, W of x is, because we have to calculate C of n in the series, so we need this weight function W of x. Because what is C of n? Can anyone tell me? You have already done these things in your lecture series. Is it fine? Have you learned? Hello?
Yes, ma'am.
Okay. So here f is, how to calculate the inner product of f comma g in this case? The boundaries condition are, in problem third we have given the boundary condition y1 0 y of e0. So for the limit you will use the boundary condition and weight function f of x, g of x, d of x. So the weight function is here, w of x is 1 by x and f of x is e की power x. This is f of x. In the question we have given f of x, and g of x is sine n pi log of x. Just a minute. Batteries. Sorry. Okay. Sine n pi log of x dx. And what will be the value of g of, in this case also the weight function is w of x 1 by x and g of x is sine square, because at the place of f here sine square n pi log of x d of x. So the Cn you will get and okay, so this is Cn, inner product of f comma g and g comma g. Inner product of f comma g can be written as, from the boundary condition the limit will become 1 to e w of x, f of x, g of x. So put the value of w of x, f of x and g of x. You will get the integration and you will get the integral of this inner product of g comma g. So you can write the Cn as, and you can simplify this integration. I haven't solved this integration, so this is your homework, or you can solve this integration. I haven't done this integration, so I'm not going to simplify this integration. You can do this thing Okay. You can put log of x is t, and the denominator integral become 1 sine square t dt, and you can simplify. And in numerator you can apply the product rule after substituting log of x is t, and you can simplify. This is your homework for, you can simplify Cn and you can get the answer. So the question was, expand the function f of x in terms of the eigenfunction. So e की power x can be written as this because this is eigenfunction. Fine. With the help of problem 3, just wait. With the help of problem 3, we can compare this equation 1 and we can obtain the weight function, as we need this weight function for calculating the integration or inner product of f comma g. So are you getting this concept? Is
Okay.
there any doubt? Can you calculate the integration? You can calculate, this is your homework, okay? Because I haven't done this integration. Okay? Okay, let's move to the next question. Yes?
Ma'am, can we express any function just like this?
Yes,
this type
you
of
can.
item?
You can express any function in the form of series, in the form of eigenfunction. With the help of eigenfunction, you can express any function, but you have to calculate Cn.
Okay.
Okay. Yes, Krishna Swami.
Madam, write the answer, madam. I will check.
Okay. The answer is, I'm not sure about the answer, but maybe the answer is, so this is the answer, I think. Please check. I'm not saying this is correct answer, but the answer is in the form of this, maybe, because I haven't checked the answer, so I'm not sure about it. You can solve the integration and check the answer. Is it fine? You have to calculate the integration. Okay, let's move to the next question. Question number 6. Again, expand the function in terms of the eigenfunction of the problem 4. So the problem 4 was e की power 2 of x y dash plus e की power 2 of x lambda plus 1 y of x is equals to 0. Again, you can compare what will be the value of px, qx and wx. So I'm going to write only w of x because we need only w of x in this case, e to the power 2x. So we have to expand x square in terms of eigenfunction. What was the eigenfunction? In this case the eigenfunction was question number 4. The eigenfunction was sin nx e to the power minus x. So you have to express in the form of sin nx into e to the power minus x. Now again Cn what is f? X square. What is g? This is g of x. So again, and what are the boundary condition? Boundary condition was, so the limit till e to the power 2 of x, this is w of x, weight function. Okay, I'm going to write first of all f comma g. So f comma g is 0 to pi w of x, f of x, g of x dx. So what is w of x in this case? W of x is e to the power x, and f of x is x square, g of x is sin nx e to the power minus nx. So can we write Cn integration 0 to pi w of x is e to the power x, sorry, e to the power 2 of x, f of x is x square, g of x is e to the power minus x sin nx dx, and 0 to pi w of x is e to the power 2x, and g of x product will e to the power minus 2 of x sin square nx. Fine. Or this integral become zero to pi sin square nx dx. The integration of denominator will become pi by 2, and I haven't calculated the integration of numerator, so again you have to simplify Cn. Fine. You can use the integration by parts and you can simplify. Fine. Yes.
The previous step, it is e power x or e power 2x, no?
Sorry.
In the step, the previous step, it is e power x or e power 2x.
W of x is e to the power 2 of x. Compare this equation
Okay.
with
Next
this.
step, no? Next.
So,
Final step.
okay,
Last
okay.
step.
Okay, last step. This will become 1. This will become e to the power x. This is correct.
Okay.
Okay, mute yourself. Okay, next question is, question number 7 is, find first 4 terms in the Fourier Legendre series of the function f of x is equals to cos of pi of x upon 2. What will be the Fourier series for this function? Fine. En is the Legendre polynomials. Legendre series can be written for any function f of x is equals to Cn En of x, where Cn is 2n plus 1 upon 2 minus 1 to 1 f of x En of x. You have already done this in your lecture series. From there you can see the value of Cn. Okay, have you learned about this? In your lecture series about Fourier Legendre series?
Not yet seen, ma'am, these videos.
Okay, you can see the recorded videos of lecture series, then you will get the okay, recall the Legendre Legendre equation. I'm going to give the hints. Call equation, Legendre equation 1 minus x square y double dash minus 2 of x y dash plus alpha plus 1 y. This is Legendre equation, and from here the operator will, you can see the video lecture, then these things will clear. Okay, the Legendre series will given by f of x is equals to, I am not going to derive because these things you can check your lecture series. The f of x is summation Cn Pn of x, and in this case Cn is given by 2n plus 1 upon 2, because Cn in this case minus 1 to 1 f of x Pn of x dx and minus 1 to 1 Pn of x square. The value of denominator is 2n plus 1 upon 2, so I am writing Is it fine now? You can see your lecture series in which the derivation is written in the detailed manner, so you can check the value of Cn for the Legendre polynomials. For the Legendre series, the coefficient of Cn is 2n plus 1 upon 2 minus 1 to 1 f of x Pn of x dx, where Pn is the Legendre polynomials. Now you have to calculate the first 4 terms. So for n is equals to 0, C naught 1 by 2 minus 1 to 1. What is f of x? Cos of pi of x. Pi of x upon 2. This is f of x given in the question. X P naught x. What is the value of P naught of x? We have already done in previous lecture Roderick formula. Pn is the Legendre polynomial. What is the Roderick formula? From here you can substitute the value of n 0, 1, 2 and so on. You can find the please recall the Roderick formula, so that from here you can calculate P naught of x. P naught of x, you will get 1. You can check. So C naught so after simplifying this integration you will get 2 upon pi. Now please tell me the value of C1. In the similar manner you have to calculate the value of C1 and give me the answer. I am waiting. What is P1 of x? Put the value of n is equals to 1 and tell me the value of P1 first of all. From here.
X, ma'am.
Yes, P1 is x. So what will be the value of C1? 2n plus 1 upon 2. That means 3 upon 2 after putting n is equals to 1. And function is f of x is cos pi of x upon 2. And P1 of x is x dx. So this is odd function. Isn't it? Even into odd will odd. So the integral will become 0 because the limit is from minus 1 to 1. So the integration of odd function will become 0. This is the property of proper integral of two function, or you can say odd function. Fine. Now C2, 2n plus 1 upon 2. So at the place of n you have to put 2. The coefficient will become 5 by 2. Cos of pi of x upon 2. What will be the value of P2 of x? You can calculate because we have already done in lecture 5, I think. P2 of x we have already calculated. The value of P2 of x you will obtain 3x square minus 1 upon 2. Now you have to integrate this term. it can be write 0 to 1 into 2, because cos of pi x upon 2 into x square is even function, and the integration of cos pi x upon 2 is for 2 by pi. We have already calculated in. Fine. These are the simple calculation. No need to worry. You can simplify by yourself also. So, integrating by parts. Into 2x cos pi of x upon 2, 0 to 1, minus 2 upon pi q, zero to 1, and this minus 1 by pi. Fine. Just apply the integration by part. You can check the calculation at your home. After simplifying, I am going to write the answer. Okay. Three into 2 की power 4. This is power. Simplifying, you will get 25 by 2 pi minus 120 upon pi cube. So this is the value of C2. Again C3. So the coefficient 2n plus 1 upon 2 will give 7 by 2. F of x means cos of pi x by 2. And P3 you can calculate. We have already calculated in lecture 5 the value of P3. Sorry, this is Q. Again, this is odd function. This is odd and this is also odd, because this is cubic, this is power is 1, this is odd function, this is product of the odd and even. This is even, but this is odd, so the overall function is odd, so the integration will give 0. Fine. Okay, we have to calculate four terms. So P0, P1, P2, P3 will give 4 terms. So P0 is pi by 2 upon pi, P0 of x. Substituting these C1, C2 in this series. Let's say this is equation A. Is it fine? Is there any doubt in this question? Fine. Is there any doubt?
No, ma'am.
Okay, let's move to the next question. This is last question for today's session.
Wait few seconds, brother. Please answer.
No need to worry about the lectures PDF. You will provide
Okay,
it.
madam. Okay.
Okay. The next question is find first three terms in the Fourier Legendre series of the function is 0 when x is from -1 to 0 and x when x varying from 0 to 1. Again, the similar question 7, the Fourier Legendre series is given by f of x is equals to c naught or cn pnx. Fine. And what was the value of cn? 2n plus 1 in the previous question. You can see your lecture series. Fine. So now you have to calculate c naught. 1 by 2 minus 1 to 1. What is f of x? So f of x, e naught of x is 1. And what is the value of f of x? In the interval -1 to 0, f of x is 0. So can we write direct 0 to 1? Because in the interval -1 to 0, f of x is 0. So no need to write the interval -1 to 0. So I am going to write the interval 0 to 1. F of x is x into 1 dx. Fine. So c naught is 1 by 4. Similarly, the c1, 2n plus 1 upon 2. So this will give c 3 by 2. Again I am going to write only the interval 0 to 1. F of x is x and p1 is x. P1 of x is x. You can calculate by Rodrik formula, and after calculating the integration you will get 1 by 2. Similarly, we can calculate c2, 2n plus 1 upon 2, that means 5 by 2, 0 to 1, f of x is x. P2 of x is 3x square minus 1 upon 2 by the Rodrik formula, and after substituting the limit you will get 5 by 16. You can calculate. So first three term. The question say first three term. Find first three term in the Fourier Legendre series for the function. The first term is C naught P naught x. Second term is C1 P1 x, C2 P2 x. So you have to substitute these values. You will get f of x. What is C naught? 1 by 4 into P naught of x plus C1 is 1 by 2 P1x plus C3 is 5 by 16 P2 of x. So this is the answer. Okay, is there any doubt in this question? Ask me if there is any doubt.
No, ma'am, no doubt.
Okay, so that's all for today. That's all from my side. Okay. If you have any doubt in these questions, you can ask me. We have 2 more minutes. Okay, that's all for today. We can leave now. Thank you all of you.
Well,
Yes,
hello, madam.
yes.
Madam, the problem solving link that we sent.
Okay, I will send you the link. If you have
Okay, ma'am.
not get the link, I will send the link. Okay. Thank
So
you,
where will
everyone.
get the me?
Yes.
Mail.
Sorry.
So how we will get the link?
You have provided the link on your Swayam site for of the NPTEL.
Okay. Okay.
Okay.